Look at this visualization. It captures the sheer speed of modern cloud infrastructure. Compute nodes spawn, form complex clusters, and dissolve entirely in milliseconds. But if we freeze this rapid cycle, a severe operational challenge emerges. The physical state of the cloud is highly ephemeral. Because resources are constantly created, modified, and deleted, identifying configuration drift or proving historical compliance quickly turns into a retrospective, manual guessing game. AWS Config was built to solve this exact problem. It operates as a continuous state tracking and evaluation engine. It captures these fleeting infrastructure modifications and locks them into an immutable chronological ledger. To understand how it achieves this, we are going to trace the exact data flow of a single resource change, step by step, from the moment it occurs all the way through to an automated compliance remediation. At enterprise scale, the volume of these changes quickly exceeds the limits of manual oversight, creating a visibility gap that only automated tracking can close. Let's start at the source. Imagine an engineer updates the security group attached to an active Amazon EC2 instance. As this architectural diagram shows, the foundation of the system is a sensor block known as the configuration recorder. It actively monitors your supported AWS resources. The exact millisecond that EC2 instance's state mutates, the recorder captures the precise parameters of the change. The critical output of this process is the generation of a discrete unit of data called a configuration item, or CI. If we expand the CI, you can see it contains a highly structured list of resource attributes, metadata, and current configurations. Each configuration item acts as a locked point-in-time record. Once generated, its contents cannot be altered. This makes the CI the atomic unit of cloud governance. It guarantees that absolutely no infrastructure modification happens off the books. So where do these newly generated configuration items go to become actionable intelligence? First, they are routed through a pipeline that delivers them directly into an Amazon S3 bucket, building a persistent configuration history. By storing these records over time, your teams can generate comprehensive configuration snapshots, revealing the complete state of the entire environment at any exact moment in the past. Historical records are essential for auditing, but operational teams responding to sudden outages also require near real-time visibility. To solve this, a secondary data flow splits off from the main pipeline. This creates a configuration stream, delivering instant state change notifications via Amazon SNS. External tools and automated systems can subscribe to these streams, allowing them to trigger immediate secondary workflows the moment a resource shifts. By splitting the pipeline, architects guarantee that engineers maintain both immutable historical auditability and zero-latency operational awareness. Tracking state changes is highly useful, but true governance requires the active enforcement of security standards. We add that enforcement by inserting a logic gate into the flow, known as a configuration rule. This defines a strict compliance requirement, such as mandating that all S3 buckets remain encrypted. Every time a new configuration item is generated, the engine instantly scans it, comparing the new state data against the parameters of the rule. The outcome of this evaluation is strictly binary. The resource is instantly flagged as either compliant or non-compliant. If a resource is non-compliant, relying on a human engineer to manually log in and fix it directly introduces latency. During that delay, the system remains completely vulnerable. We remove that delay with automated remediation. Utilizing AWS Systems Manager, the engine instantly loops an automated corrective fix back to the original source resource, immediately restoring its compliant state. Architects can customize these remediation actions extensively to ensure they match their exact operational procedures and internal security protocols. This closed-loop system removes human reaction time from the compliance equation entirely, eliminating the window of vulnerability. Let's expand the scope to evaluate the blast radius of a single change. This node map shows how a single AWS identity and access management role connects to a Lambda function and subsequently to a security group. AWS Config maps these dependencies using resource relationship tracking. If the IAM role is modified, you can track the resulting ripple effect across all connected resources. Visualizing these relationships allows architects to reveal critical downstream dependencies and prevent unexpected outages before executing massive infrastructure updates. Without this mapping, manually auditing thousands of resources across multiple regions looks like this void, countless disorganized data points scattering wildly with no coherent connection. To impose order at an enterprise scale, organizations deploy conformance packs. These are modular, standardized collections of rules and remediations that can be dropped into multiple accounts and AWS regions simultaneously. Then an aggregator capability pulls the resulting compliance data from all of those scattered regional nodes inward, merging it into a single centralized view. Security teams can now identify global compliance trends and enforce standardized policies across the entire organization without constantly switching between individual accounts. By combining conformance packs with aggregation, you translate localized infrastructure tracking into globally scalable enterprise governance. In practice, this architecture functions as a precise time machine for IT operations and security investigations. This dashboard displays a chronological timeline UI. During an investigation, security analysts can scrub backward through this history to isolate the exact moment unauthorized IAM permissions were expanded. Operations teams rely on that exact same timeline during service disruptions. By rapidly identifying the most recent root cause change, they drastically reduce mean time to resolution. The system is equally effective for resource optimization. Finance teams can query the config inventory to locate unattached EBS volumes or oversized instances, stripping wasted spend from the cloud budget. And when it is time for an audit, the engine's continuous automated reporting completely eliminates the manual scramble of evidence gathering. AWS Config serves as the definitive bridge between your initial infrastructure as code deployment and your ongoing rigid governance requirements. By pairing continuous tracking with active evaluation, the service ensures your cloud environment functions strictly as architected, regardless of how large it scales. Enterprise cloud security depends on the verifiable record of how an environment actually behaves across its entire lifecycle, turning the ephemeral nature of the cloud into a permanent, auditable history.